All right. So yesterday's homework was map 2, which was on page 21. It was ugly. And I would never, ever, ever ask you to do one of these. But like I said, fourth period thought it was fun and they wanted to go ahead and do it. For the record, they didn't do a great job. They didn't do a horrible job, but it wasn't like they were like blasting away at this stuff. Here is what this map should have looked like. My
Oh,
Oh,
one spot. I missed one.
oh, lots of you missed. Are we talking about over here?
No, I'm missing the 42. Yeah.
Oh, yes. This is another spot. So the places people messed up were completely skipping this stuff over here. And then, yes, this guy is going to have 3 separate heats. So like a lot of people wanted to, and it was on either side, just skip and go down. Hang on. Nope. No ink, even though this is supposed to just like do it itself. There we go. A lot of people did this and just skipped it down to there. When you do that, wait, is this the one? I don't remember which one it is. That where you got what you guys did? Oh, yes. Yes, you did this. Because when you do this and say that there's a 40 line here, this is a 40 and a 39. Is there a 40 in between 40 and 39? No. So that's why you did connect it back up to itself. Honestly, if you didn't catch that, you're fine. I showed you guys what these would look like on the real regions yesterday, right? Did I do that? Did I show you this guy? Yeah. This is so easy compared to this. I'm going to print up a few of these to do these tomorrow to see how you do. So you can see what's really.
I did on the 42 right bottom.
Yeah.
Circle. I connected it to the top left 42. Like right up. And then to the left. That 42 is the one I connected that to.
This is a 40, not 42.
40, that's on 40.
Oh, okay. Oh, so you went like that and skipped again. Same deal than when you did. Oh, maybe that would have worked. I'm trying to think if that's a problem. I don't think either way would be wrong in that case. Yeah, I think that should be fine too. Either way, like I said, this is overly complicated for what they're ever going to ask of you. So if you didn't get all of those details, that's fine, because this is seriously what you have to do on the real Regents is so easy to connect just the 30s. That's one line. That's it. And then you have to do the 40s as well. You just have to make sure that, whoops, you're getting everything higher and lower where they belong. Like, that's it. That's nothing compared to what I had you guys do. So I am not concerned if you did not get page 21 to the T. But I will say, especially if you missed these ones over here, which a bunch of you did at the beginning of, or when I had you guys working on it yesterday, if you're checking your work every single line you draw, you won't skip one, you won't mess up. Every time you're done drawing a line, go through and check. Everything on one side less, everything on the other side greater. You wouldn't have missed these 25s and 31s over here if you had done that. But with that being said, anybody like majorly confused with these? All right, we just have to finish up our notes from yesterday. So we are on here. I believe this is where did we do the benchmark in our class?
Yeah.
Okay, so I'm not sure if I got to that one with all of my students. I want to show you, I don't think I showed you this. This is not a real benchmark, but this is what they do look like. I showed you this exact one?
Maybe not that exact.
Okay, yeah. So this is an easier to see one. This is about the size they are. They are mounted on like a very deep cement post. So, I mean, I guess technically somebody could steal them. But nobody, I don't think, cares, first of all. And it would take an effort to steal one or to move one. So like they're permanently stuck in the ground. What's missing from this one, it does tell you it's from the Grand Canyon. What would have been filled in here would have been the exact latitude and longitude of the Grand Canyon at the South Rim. And then they tell you the elevation at that dead spot. So 7,120 feet above sea level. The thing with benchmarks is they aren't necessarily any spot that's special. It just might be the spot where that scientist is like, here looks good. So they're not necessarily the highest point. They're not the lowest point. They're not the best place to build a house. They're just some random spot that somebody decided to say, okay, the elevation at this random spot is 7,120 feet. So they're not as special as one might think. That leads us to a depression. So you know what? I'm actually going to go on to the PowerPoint because I want to show what these look like. All right. So a depression. If somebody is depressed, and I don't mean to downplay depression because depression is a huge thing, but if someone's being depressed or is depressed, can we say that they are feeling low? I mean, I know there's a lot more to it, so please don't let me downplay depression, but if you're depressed, you're feeling low. Or if somebody, I don't know who actually talks like this, but I'm sure you've heard this. What does it mean if I depress this button? Press it down. By the way, this does absolutely nothing. I think I told you at the beginning of the school year. But a button that is depressed means a button that is pushed down. So a depression on these maps, what do you think a depression is? A low spot. So it is, oops, sorry. Cut that part off. So depression is shown with these little marks here. By the way, let me show you all, you know what? How about you write these and then I'll talk. Write this, and yes, I do think you need to write this word for word. So you might have to write small. It's going to take you a minute. Take your time, write it. We'll get it in your notes.
That word, that B word.
It's a W word. So that button, so maybe I didn't tell your class. So that whole situation controls the gas that would come out of these little doodads here. So if you actually might have ever seen me stand here and do this with them because I'm bored, or just not even notice, not that I'm bored, just don't even notice I'm doing it. This is where gas would come out. But to make gas come out of there, you have to put a key in here and then turn the on button on. I don't have the key, so I clearly have told some of you. So I don't have the key, but if I did have the key and it was on, this is the emergency shut off button. But since I don't have the key to turn it on, the emergency shut off does nothing either. But anyway, so these they're also called hatchard marks. I've seen them both ways. Just they're these little lines. They're supposed to represent an elevation decrease. And I think they kind of do, like if you maybe using your imagination, but I think this gives the best impression of a hole being in this thing that looked like it was going up and now we have a hole. To me, this actually reminds me of, you've ever seen the movie Jaws? Okay, and it's a movie about a shark, and the animation or the special effects were great at the time, but now watching it, it's ridiculous. The shark, for those of you who don't know, looks like a giant barrel with a mouth on it, and it looks ridiculous. But one of the scenes is this shark is opening its giant mouth, and it has teeth coming around it, and it reminds me just of this. And inside the shark is just like a big gaping hole. So I don't know if that helps any of you, but when you see something that looks like this, it reminds me of a shark opening its mouth and a big hole appearing. So this is supposed to be showing a low spot or a hole on the top of this mountain. By the way, what are some things that could cause a big hole on the top of a mountain? Rain could do it. They could lower and make a dip. What else could do that? A lake. I don't know about a river, not a big. What about a volcano? You ever seen a crater in a volcano? It's a big gaping hole in the top of a hill. A meteor could have caused a big hole like this, or people that could be a gravel pit like we have around here, a big giant hole created in the ground. So just a big gaping hole. So that's supposed to be representing a hole. Now, this second set of information, this is probably the most important part of what's up here. And it's also kind of weirdly written. So let me explain what it means. So notice how all of these lines here, they were going up 20, 40, 60, 80, 100, and then 100 repeats itself. That's the first part here. It says the first depression contour has the same value as the previous contour line. So again, what that means is here, this was 100. This first line with the little marks on it is also 100. And then any others count down with the same interval the other ones were going up by. So again, 0, 20, 40, 60, 80, 100. 100 repeats itself, and then it starts going down by 20s. So then we're down to 80. So 100, then 80. The next one would have been 60, etc. That's a depression. This is also a picture of an island, this whole map. How do I know that this is an island?
There's a 0.
What is the 0 line telling you?
What's that? Sea level?
That's sea level. Basically, it's saying that this whole island is surrounded by the sea. So anytime, so island is the next word. If the first contour line is 0 all the way around, it's an island in the ocean. I should have probably followed that by in the ocean. An island in Lake Erie would not have a 0 going all the way around it because Lake Erie is not at 0 meters above sea level. And the last part, I need to do some pretending. That benchmark right there. When we went over benchmarks, did I say that that means 123 is the highest elevation on the hill? I did not. A benchmark is, again, just some random spot. So that place that's labeled 123 is, yes, that spot's 123, but it's not necessarily the highest spot on the hill. I want you guys to think about this for a minute. So clearly this is the highest side of the mountain. By the way, how did I know this is the highest spot? It's the only place that has something in the 120s. I need you to figure out what could possibly be the highest spot. What could be the highest peak on this mountain? What number would it be?
129.
You guys are so close.
129.
No.
128.
Nope.
Oh, 139.
139, is that what you're gonna say? Thank you. Why 139?
Oh, 139.
Because it goes up by 20. This goes up by 20.
Oh.
We don't go up by 10. So those of you who said 129, you forgot that these lines were going up by 20. So for those of you who have no idea where this number came from, I'm going to walk you through it. So we clearly have an elevation of 120 here on the map. Do we have an elevation of 140? How do I know there's absolutely no 140s on this map? Because there's no 140 line. The rules state you would have had to draw the 140 line. So there is no 140s on here. But do we draw lines for every single number that's on the map? No. So 139, could it be there?
Yeah.
Yeah, because we don't know. So how do you figure out what the highest possible elevation is?
Good luck for the highest number.
But no, because that's 120.
Yeah, but the outside.
No, but that's, you guys just told me the highest possible elevation is 139. One below what would have been the next line. So the regents might ask you, here's the map. What is the highest possible elevation on this entire map? 139. And here's how you do it. It is one less than what would have been the next contour interval. So then I did the example for this one. So we had 120. Add 20 to that. Where did I get the 20 from, by the way? It's the contour interval. So the next one would have been 140. And then just subtract 139. Highest positive, that's always what you do. You go to what would have been the next line and subtract. Now let me see if you can, wait, I'll let you guys finish writing, sorry. So how could we then take that information? And let me ask you this. Here's that depression, that hole. They might now ask you, what is the lowest possible elevation in this hole? Think that one through for a minute. What is the lowest possible elevation in this hole? Go follow the same set of examples. Some of you are saying the right answer. So let's talk, I'm hearing a whole bunch of different answers. Is the lowest necessarily 80? No. There's all this space in between here. So is it 60? Why is it not 60? Because there's not a line. So is it 59 or 61 is the lowest possible? Why not 59? That's even lower than 60. So lowest possible elevation is slightly different than highest. In that case, because we don't want even lower than the next line, because they would have had to draw the 60 line if it was lower. So we need a little bit higher than what would have been the next line. So that would have been 61. So that's the end of those notes. So let me go through again what the Regents is going to ask of you. They're going to have you take and draw one of these. That's one thing that they're going to have you do. And again, not draw it like we did in homework. Draw it like that example I showed you. So one thing you have to do is be able to draw these. And then you have to be able to look at this map and tell me if I put two spots, like if I put an A and a B. They might say, how far apart are A and B? What would you do to find out how far apart A and B are? Use the map scale. So when I say how far apart, that's distance. So you use the map scale. Then they might ask you, hey kid, what's the elevation of A? Or what's a possible elevation for A? How would you do that? Okay, so we know this line is 20. We know this line is 40. What could A be? 30. Does it have to be 30, by the way?
39.
Could be 39. Could be 21. It's anything in between 20 and 40. Again, this didn't say what's the highest possible elevation. It just said what is a possible elevation. So that's one thing that they could make you do. They would ask you which way the stream is flowing.
North.
You could say north. And then they're going to follow that up with how do you know it was flowing north? Okay, so there's two ways.
Arrow.
No, not that arrow. Pretend that's not there.
The highest elevation or lowest elevation?
Highest to lowest elevation, that's one.
Or the dips.
Or the dips. Remember that these dips, the water always comes out of the dips. Then they could say, hey kid, what's the steepest side of the hill?
The left.
The left. Now they'll probably ask you north, south, east, or west. So in this case, it's the west. How did I know that's the steepest besides that it's labeled?
The closest.
Lines are closest together. They might say, hey kid, which side of the hill is the gentlest slope? That's the east side. And how did you know that? Because the lines are far apart. They might ask you, like we did, what's the lowest possible elevation or the highest possible elevation? Those are all the things they're going to ask you about these maps. Draw it, answer questions, and then the next thing they're going to ask you is to draw a profile of this map. Do you guys know what a profile is? If your art teacher asked you to draw a profile.
Explain what it is.
Kind of. No.
Explain what's going on.
Oh, what's a profile in art class?
Side.
The side view.
Oh.
A profiles is, you guys have probably done this before where you stand in front of a light source and then you can trace your profile on the board behind you maybe. So if I was to do mine, you'd be able to see my forehead, my eyelashes, my nose,
Yeah, we did this.
some lips. And there you go. There's the side profile of me. You can tell I don't think very highly of myself based on that profile. There you go. So that's a side view. We're going to do the side view of a hill. But the side view of a hill can't be quite like what I just did in a rough example. We are going to draw this to scale based on this map. So there's a few details that you have to make sure you follow when drawing these profiles. So we have 12 minutes, which I think is just the perfect amount of time. So if you flip over to page 24, there is a small reading here. We're not going to read this right now. This is just a spot out of a textbook in case when you're doing these or reviewing and you don't remember what the heck a profile is, it is up here. I do just want you to remember it is, so add this, a side view of the mountain. It's a side view of the mountain. The directions are up here in this reading along with an explanation, but what I've done is there's these steps. Now there's other ways to do it, but so to be honest, when I started teaching earth science 16 years ago, I had no idea how to do these. So I taught myself how to do them. And when you teach yourself or when you learn something right away, like you get really good at explaining it. So that's why I've broken it down into these 6 steps. If you follow these 6 steps, I guarantee you will always do them right. Are there other ways? Yes. I'm not going to teach you them. If you figure them out, good for you. But if you do it this 6 ways, I promise you, you will never screw up. So up here is an example of a map. Can you guys kind of describe to me if you were to walk along A going to B, what can you expect? Your hike is going from A to B. Let's start at A. Uphill, and then you start going downhill. Are both sides of the hill the same? No. So what do we got going on here? How do you know one side's steeper, one side's not? So this side, they're far apart. So going up the hill, what can we expect? Going from A to this side, up the hill. A really gentle hill. Then what happens? Then the steep part. We are going to draw this to scale now. And we're actually going to do, if you notice on this page, it's the exact same map. So we're not going to do it right while we're taking the notes. We're going to take the notes of the steps first, and then we're going to practice it on the following page. Are you ready for the steps? Okay, whether you're ready or not, here they come. Sorry. Step 1. Maybe. Step 1 is determine the contour interval and write it in for each line. By the way, I also think you should write these in the boxes word for word so you have a perfect explanation of how to do this. We're on page 24. Easy enough, right? So this one, the one I have on the board, I have a 20 labeled and a 60 labeled. What are the lines going up by? Wait,
Oh,
they're going up by 20s, 20 blank 60. So yes, they're going up by 20s. What you need to label though is the ones that are missing. So don't bother doing the one yet. We'll do it all together in a second. Step 2. This one's weird. Write it and then I'll explain. Again, I recommend writing the whole thing word for word. So it sounds weird, but I promise it's not as bad as it sounds. So it says, place a scrap paper along the line to be profiled. So that's this. Take your scrap paper and put it along. Again, we'll do it all together in a minute. You put it along the line that you're going to profile. Then the second part is mark each place the contour line touches it. So you'll do like these little lines and label it. So in this case, I labeled where the 20, the 40, the 60 touched it twice, then back to 40, and it did not reach over to the 20 on this one. So again, don't try this yet. We'll do it all together in a minute. Now, I mentioned that this is going to be drawn to scale. So we're going to put it on what looks like a graph. It is not a graph though. It is more like a drawing on graph paper. The reason I say this is it is not, we do not follow the rules for graphing. So step 3, place your paper on the x-axis. Yeah, again, let's get everybody to get 3 first and then I'll go back. Everybody go to step 3? Okay, going back for a moment to step 2. Okay, so again, step 3, you have your scrap paper with all the little marks on it, and you're going to put it on the x-axis. Again, it's not really an axis because it's not really a graph, just looks like one. Step 4 is another one of those ones that's a little weird until you try it. So go ahead and write step 4 word for word, and then we'll explain what that means. It doesn't look like we're going to get to trying this out yet today either. So you made your scrap paper look like this in step 2. Step 3, you moved it under the x-axis. Now, step 4, for each of these marks on your scrap paper, so for this one labeled 20, you're going to put a dot directly above that mark on the 20 line. Same with when we get over here to 40. You're going to bring it right up to the 40, 60, 60, and back down to 40. So remember, I said this is not a graph. It does not follow the rules of graphing. These do not have to be evenly spaced. They do not have to go in order. The x-axis is whatever your scrap paper was. So again, your scrap paper came from this step. So marking down each one on the map or from the map. Step 5, connect the dots. But before you connect all of them, we need to do step 6 as well. Step 6 says hills are not flat. So what I'm talking about here is where the 2 dots for the 60 are. We don't just connect these in a straight flat line. They're a hill. We know that they go up a little bit. So you do curve that hill up at the top. So you do have to make it go up above the 60s. But by the way, where can it not touch? The 80. So I know there's no 80 on this graph, but you have to curve that up above the 60, but make sure it doesn't touch an 80 because there are no 80s on this map. So we ran out of time. We'll go ahead and practice this tomorrow. So we'll keep the notes and practice it tomorrow. And no, you do not have homework.
Can I have one for tomorrow?
Nah.